So for this lesson, I'm going to talk about the discriminant. Alright, so you understand the discriminant in relation to a quadratic equations. This is a very quick 5-minute crash course. So in discriminant, there are a total of 3 types. Okay, there are a total of 3 types of mean situations. Number 1 will be real and discriminant. So discriminant, as you remember, will be equals to b squared minus 4ac. So why do we choose this to be discriminant? Because really it discriminates. Alright, so you know that if you are going to solve in general, say a quadratic equation, where's ax squared plus bx plus c is equal to 0, and the quadratic formula, you recall that you've studied this, is negative b plus minus b squared minus 4ac over 2a. So you see, the interesting thing is, right, if you let's just look at maybe this portion, you can see that if b squared minus 4ac is a non-zero, say maybe it's greater than 0, right? What are you going to get? You're going to get actually probably, let's say it's like maybe equals to x or something like that. You're going to get 2 different solutions. So you're going to get x equals to negative b plus square root b squared minus 4ac. Let's say you just call it maybe d. So you call it d, right? Discriminant, right? Okay, so here this means that the negative b plus minus square root d, right, over 2a. So this will actually give you so-called 2 distinct or 2 different answers. Right, what happens if it's equals to 0? What happens if b squared minus 4 is equal to 0? Then you can see that you basically just get x equals to negative b plus minus 0, which is nothing, right? So it's 2a. Right, so actually it means that if the discriminant is 0, you just get 2 repeated or equal roots. Alright, and then if b squared minus 4ac is less than 0, then you can see that, you know, if you have square root d, this one is basically undefined because you cannot square root a negative number. So otherwise, you'll see this as 2 unreal or complex roots. So these are the 3 situations for discriminant. And discriminant, you can see how are we going to tell the nature of the roots, mainly from this portion, from the quadratic formula, and this discriminant really because it discriminates, right? You use the function is to tell you whether the quadratic equation has a solution or not. Okay, so what are the another type? So typically you must remember, a lot of times typical question is they'll give you something like they give you something like, oh, find the range of k for which something like bk square x square minus 2 plus kx plus k equals to 0 has 2 real and distinct roots, something like that. So a lot of times you are using this, alright, to form a quadratic inequality. So probably to give you something like 2 plus k square minus 4k square k are more than 0, since we are talking about real and distinct. So if you were to solve this, you're going to end up solving a quadratic equation. So quadratic equation, I tell you, you must always remember to draw the graph, happy or sad face. So an important concept is that you must also know what's quadratic inequality. Okay, another type of a situation for discriminants is that it's not only about equating the graph. So if you're talking about ax squared plus y equals to ax squared plus bx plus c, right, if it equals to 0, okay, then of course in visually, you know that if the graph looks like that, all right, where, you know, a is positive, right, it can look this way, right? Okay, this is the x-axis, right, and this is a is negative. These 2 situations are what we call real and distinct roots. All right, because you can see there are 2 intersection point, 1, 2, 1 and 2. Okay, you can see that the discriminant is positive. Alright, so graphs like this, you can see that it touches the graph 2 times. Okay, whenever equals to 0 has 2 solutions. The second one will just be the trivial mean. You touch it at probably 1 point, right? Okay, you touch it at probably 1 point. Okay, so an example of a graph like maybe like y equals to x squared. Okay, or y equals to x minus 2 squared, or y equals to negative x squared, y equals to negative x minus 2 square. So an example of a graph like this. How about this? This is probably something like y equals to x minus 1 bracket x minus 2, and the solutions here will just be 1 and 2, something like that. Okay, so the second situation, discriminant is equals to 0, and you have real and equal roots. Okay, what about the third kind? The third kind would be really the discriminant is less than 0. This means that if you talk about x-axis is like y equals to 0, and this one is like your y equals to fx. So y equals to fx, right? You can see that y equals to fx does not cut the x-axis. Does not cut x-axis. This also means that if I try to equate the two lines together, maybe one is y equals to fx, and the other one I try to equate y equals to 0, which is the x-axis, right? You try to solve them simultaneously. This one have no solution, right? Because they don't intersect at all. Okay, so that means fx equals to 0 actually has no solution. Alright, when you have no solution, what does it mean? It means that you have unreal roots, right? Alright, so if we try to solve f equals 0, you realize that the discriminant is less than 0. So there are a lot of ways which the question phrases this. They also say things like, find a range of values for which it lies entirely above the x-axis. Okay, they also say things like find a range of values which is completely positive, always positive. So you see keywords like this, it straight away means that your discriminant is negative. Alright, or you can even see things like always negative. Can it be always negative? Yes, it's possible. Example like that. Alright, where maybe your y equals to fx and the coefficient of x squared is negative, is a set face. Okay, and a lot of times the graph like this actually comes from completing the square. Okay, not only are we referring to one graph, sometimes we can refer to the one line. Okay, so let's say maybe we talk about another one, something like that. Maybe y equals to mx plus c and y equals to fx, for example. Maybe let's call it gx. Okay, you can see that if I try to solve the equation fx equals to gx, right? Okay, how many solutions will I get? You can see that I'll get 2 solutions. So this means that, if I solve, I try to equate fx minus gx equals to 0. This should have 2 solutions. 2 solutions meaning what? If this itself, right, it's going to give me a quadratic equation. Right, what can you say about the quadratic equation? 2 solutions. This is also going to be a quadratic equation. You can say that the discriminant will be more than 0, right? This means that they intersect each other at 2 points. What about if they were to intersect at 1 point? Say this is fx, then y equals to gx. Okay, then this means that they only have 1 solution. Then if you take fx equals to gx, which is the same as fx minus gx equals to 0, this one has 2 real and equal roots. Alright, and what if it doesn't touch? This means that this one, you'll see things such as the word tangent coming out. Tangent also means that it cuts 1 time. Okay, so I hope with that you get a quick recap of discriminant. I look forward to seeing you in class. If, for example, something like that, this is y equals to fx, this is y equals to gx. What if they don't touch? If they don't touch, it just means that the fx equals to gx has no solution. Alright, has no solution. Okay, so if it has no solution means what? If I equate fx minus gx, alright, this one equals to 0, right? If this is going to give me a quadratic equation, what's the characteristics of the quadratic equation? It's going to give you an equation where discriminant is negative. Alright, so they will also say things like, find the range of values for which fx is entirely above gx.